All right, let's take a look at these, okay? Let's start with the easy ones here. The mode?
1.
Whoa. The mode is 1, okay? Good, because it occurs 22 times.
Correct.
So the mode is 1. What'd you get for the median?
1.
1.
All right, let's take a look. How many people do we have total here?
55. 90.
55?
Yep.
All right, 39, 45, 55, good. So which score are we looking for?
28.
And 26.
The 28th score? 55 divided by 2 is 27.5, so you round up. It's the 28th score, okay? The 28th score. All right, so the 28th score, here's 10. If you add all these together, that takes us up to number 30.
So it's in between.
So it's going to be one of these number ones, right?
Yeah.
One of the number ones is our median. So 1 is the median as well. Okay? Then we need to find the mean. Okay?
1.49.
No, 1.64.
Alright? How do we find the mean?
You.
Someone want to explain what they did? Hannah?
I took the x's and multiplied it by f, and then added those all together.
Correct.
And then divided it by the total of the f.
Good, good. So you took the scores times their frequencies, the x's times the f's, all right, and you added those all together. All right, and then you divided by the total of all the f's, which was 55, and you got 1.49. You got 1.49?
No, I got 1.381, so like wouldn't it be 1.4?
I got 1.64.
I got 1.49.
You got 1.49? You got 1.49? You got 1.49?
We're right.
All right. We'll go with the majority on that one. Okay. Just be careful. By the way, you could do this, a lot of this in your head. Okay. That's 0, 22 plus 34 plus 18 plus 8.
No, it's telling you.
Okay.
It's 1.64.
What's 22 plus,
I got 1.49 also.
okay,
22
plus 34 plus 18
plus 18
plus 8
That's
plus
9.
8
is how much?
over 55.
Wait, it's how much?
It's 82.
Actually, 82.
Over 55.
You're probably
Wait
at
for 9,
I didn't-
89,
yeah,
09,
yeah.
09.
I didn't realize 0.
All right, so, yeah, these are all 0, so. Okay, so those are good. Those are our first statistics that we can find. Again, using the frequency table is important, okay? Being able to use that properly is important. But what I want to look at in the time we've got today is another measure, another statistic that we can calculate, and that is a measure of spread. How spread out is our data? We looked at the example earlier of the test scores, okay? And we saw the one person got a 20, one person got 100, a couple people got 42s, all right? And in all of that, you know, all the scores were really spread out. And the reality is I could have two different groups of people with the exact same mean and even the exact same median, but those sets of data could be very, very different, all right? Yes?
I'm sorry, quiz tomorrow is up to what lesson?
Just probability stuff.
Okay.
All the probability stuff. All right, so we have two measures. One is really more just a tool to get to the second one, okay? The variance is the mean of the squared differences of the scores from the mean of the set, okay? And we'll explain that in a second here. The standard deviation is the one that we use more often, okay? The variance, we can use V, or that's a letter sigma, the Greek letter sigma, squared. Okay, that's the notation for variance. The standard deviation is just sigma, okay, or the square root of the variance. Okay, so once you know the variance, you just square root it and you get the standard deviation. That's the one that's really the most useful, okay? And what that tells us is the mean distance that each score is away from the mean of the data. So if you have a very large standard deviation, that means your scores are really spread out. On average, they're really far away from the mean. If you have a small standard deviation, that means the data overall is pretty grouped, pretty close to the mean. Okay? Now, let's break down this definition, because if we understand this definition, then the formula is actually pretty easy to remember. Okay? So it says the mean. Okay, so when we're finding the mean, we're adding up a bunch of stuff and dividing by however many there are, right? Right?
Yes.
We know how to find the mean. Okay, so let's think about that. We're adding up something and we're dividing by however many there are. We're going to use n to represent the how many there are. Okay? Now, what are we adding up? Okay? It's the squared. So that means we are squaring something. Differences, that means we are subtracting something. Well, what things are we subtracting? We're subtracting each of the scores from the mean of the set, okay? Now, here's our notation for mean. It was x bar, all right? And we're going to subtract each x score. We could do x sub I, all right? So we're going to take each score, we're going to subtract it from the mean, and then we're going to square it.
So
Okay.
the sum of all the
And then, once we've squared those, we're going to find the mean of them.
The position
But the
doesn't
sum
matter,
of like,
right?
What?
The position.
I don't know what you're saying.
As far as these two, whether it's x sub I minus x bar, no, that doesn't matter. And actually, depending on what book you read, it might be backwards. In fact,
'Cause I see-
yeah, here it's the reverse of what I wrote.
Oh, please.
Okay?
Wait, so it's the mean minus like the sum of all of them?
No, you're taking each score and you're subtracting it from the mean. Then you're squaring it.
That's where I'm not understanding.
Okay?
So if it's like
So-
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it would be 5, so you substitute 5 minus 1 squared plus 5 minus 2 squared plus 5
Yeah.
minus 3 squared.
Dear God, okay.
All right. So let's do an example. Once you do it once or twice, it's actually a little simpler. I like to use a little table like this. It helps me stay organized. All right. So here are my scores: 11, 13, 16, 15, 14, and 12.
Why would you not have
All right.
them in order?
What's the mean of these? Good, it's 13.5. All right, 13.5. All right. So we're doing 13.5, and by the way, what does n equal here? 6. Okay. So that's our mean. That's the x bar, the mean. Okay. So now we're going to take each score and we're going to subtract the mean from it. So 11 minus 13.5 is a negative 2.5. 13 minus 13.5 is a negative 0.5. 16 minus 13.5 is a positive 2.5. 15 minus 13.5 is 1.5. 14 minus 1.5 is 0.5. And 12 minus 13.5 is a negative 1.5. Now, you might say, well, why don't we just average those? Well, what do I get if I add all those up?
Sadness.
Not the right thing.
If I add all those up, I get 0. And by the way, remember how we define the mean? The mean is the center by distance. These are all the distances. If I add those up, it makes sense that the distances below, the negative ones, will equal the distances above, the positive ones. So it's all going to add up to 0. That's why we've got to square all these. Okay? So we square it to get rid of negatives, and now we have 6.25, 0.25, 6.25, 2.25, 0.25, and 2.25. Okay?
And don't we like add all of those up and then divide it by n?
Yes.
Yeah.
These are the square differences from the mean, and we're going to now find the mean of those. Okay? So we add all these up.
Wait, can you say that one more time?
It comes to 5 or something.
These are the squared differences from the mean.
Yeah, from the original mean.
Yes.
Now we're taking the mean of
These. Yes. Okay? We're finding the mean of these. Alright, so these add up to 16, 17 and a half, right?
Yeah.
Okay? So guess what? Our variance is going to be 17.5 divided by 6. Okay? V is our variance. It's also, you could write it as sigma squared. Okay? Does everyone understand what I'm doing here?
Yeah.
Okay? So that's 17.5 divided by 6, which is going to be 2 and 11/12.
2.917.
2.917? Okay.
It was like 6.
Okay, good. So now, does everyone see how I got that variance? Say a question about how we got that variance.
Wait, what'd you get the 6? And you divided 17.5 by?
That's how many scores we have, right? We're finding the mean of these. So we got to add them up and divide by 6. Okay? Now what's sigma? The standard deviation.
the square root of that.
1.709.
Yeah, the square root of that, okay? So the square root of 2.917, which is what?
1.709.
There we go. Okay, so this is pretty small number. Our numbers are grouped pretty closely around the mean. Okay? So, 55. Now, if we do this with the next set, we add all those up, we're going to get 81. Okay? So 81 over 6 is our mean, right?
Isn't it the same thing?
Oh, what do you know? 81 over 6 is 13 and a half?
Yeah.
Gee, I wonder how that happened. All right? Now, I did this on purpose. Notice these two sets of data are very different. What do you think is going to happen with the standard deviation of this set?
It's
Gonna be
gonna
totally
be
different.
a bigger.
Bigger than bigger.
Yeah, it's going to be bigger. These numbers are more spread out. So let's look at that. 8 minus 13 and a half is a negative 5 and a half. 10, okay, so that's a negative 3 and a half. This is going to be 6, not 6, 5 and a half. 18 is going to give us 4 and a half. 17 minus 13 and a half is 3 and a half. And 9 minus 13 and a half is a negative 4 and a half. So now if we're squaring all of those, okay, they're all going to end in 0.25. So this is 30.25. This is 12.25. This is 30.25, 20.25, 12.25, and 20.25. Okay? I know I'm doing a lot of the arithmetic for you here, but you guys know how to square stuff. So what do I do with these numbers now? Add them up and divide by 6, right?
Yeah.
So our variance is the mean of these scores. Okay? So we've got 125.5 divided by 6. And that is 20.917. Okay? The standard deviation,
He's out.
standard deviation is the square root of that, 20.917, okay? Which would be 4 point what? Huh? 4.57, okay? So as we anticipated, that standard deviation was bigger, okay? All right, guys, thanks for your patience. Well, have a nice day. So now what I want to ask you, and what we want to explore here a little bit, is what happens if all of the data changes in the same way? Okay, for example, we might have gotten certain results, but what happens if we double everything? What would happen if everything were increased by 100 or something like that?
I would quit now.
Okay? If we change things in the same way, it's going to impact the different statistics that we're getting from those scores, obviously. Okay? So, as an example here, we had the data before where the mean, we'll use our notation here, the mean was 13.5 and the standard deviation was 1.709, okay? All right, now, what you're going to need to do in your notes, this is a part I actually added to the notes, okay? So just go below where we ended yesterday, okay? This is what I just said. In the notes that we did yesterday, okay, I added this in, all right? So just go below, you can insert a page on Notability, all right? Or in the top right corner, you see the little 2 rectangles that look like pages. If you hit that, and then the page that you're on is highlighted and you see that little blue circle with the arrow down, hit that and you can put add a page. Okay? And that'll add a blank page underneath where we left off. Okay? So, what happens when we're changing all the data the same way? We had data where our mean was 13.5 and our standard deviation was 1.709. Okay? So let's think about this, all right? I want to look at our data here, and I'm just going to put a couple of data points here, all right? Okay. So we're gonna, it won't let me duplicate, never mind, okay? So I have these data points, and they might be here, here, okay? These are all different values, okay? Now, if I took all of these values and I simply shifted them up 2, for example, okay? Let's say these are the values that we got 13.5 out of. And let's say I simply added 2 to every data point. Okay, so this one is now here, and this one is now here, this one's now here, this one's now here, and this one is now here. All right, notice all of them are just shifting up the same amount. Okay, so these red ones are the ones that we've added to every one. Okay, so to go from here to here, we added 2. Here to here, we added 2, and so on. Okay? Now, just looking at the data here and thinking about the concept, what do you think the mean of that data is going to be if the original data was 13.5?
15.5?
Good, Naya. It's going to be 15.5. We're just, when we add 2 to everything, we're just going to add 2 to the mean because everything has been shifted up 2 units. Okay? Does that make sense? Hello? Does that make sense?
Yeah.
All right. Now, as you look at these red data points compared to the blue data points, what would you say has happened to the spread, our standard deviation?
Isn't it the same?
Okay, why would it be the same?
Because if you take something and you shift it here, you keep them the size.
Okay, everything's being shifted the same distance, right? So the distance between them is all going to stay the same as well, right? So our standard deviation was 1.709. It's going to stay 1.709. All right? So when we add or subtract the same amount, it's not going to change the standard deviation. This is kind of like, any of you play the piano?
Mm-hmm.
Okay? Only one plays the piano? A couple play the piano?
Two.
All right? All right, so when you play a chord, right? You play a chord and you have your fingers spread a certain amount. If you want to go up an octave, right? You keep your fingers exactly the same and you just move up 8 keys. Right?
Mm-hmm.
So your fingers haven't spread apart any different. They're all the same distance apart. You're just on a different part of the keyboard now. Okay? That's kind of what we're dealing with here. Obviously, the sound is higher because we have changed what notes we're playing. We've added to each note to make it higher, but we get the same chord. In other words, the spread is the same. Okay? The spread is the same because we haven't moved our fingers as far as spreading them out wide or anything. Multiplying and dividing is not going to be the same thing. If we multiply everything by 2, what do you think is going to happen?
It gets bigger.
What do you think is going to happen to the mean?
By 2.
Yeah, it's going to be multiplied by 2. Okay? And what do you think is going to happen to the standard deviation?
Multiply it by 2.
It's going to be multiplied by 2 as well. Because every data point is not moving the same amount. They're all being doubled, so the space between them is also going to be doubled. So you're going to have 3.418. Okay? All right. So that's it.